Welcome back to the video series where we're making a Java maze solver. Okay, so I changed the video dimensions a little bit. I just wanted the code to be more readable, I guess. That's one of the things I didn't want to ever. I mean, I don't know. I like watching videos full screen, but not everyone does. So I want to make sure that the code is still somewhat readable for those people who are using the regular sized viewers. Okay, so where we left off. We have the maze object created for the most part now. However, at this point, we have the maze object, I guess, being populated now, but now we gotta handle that last line. Now buff rater is ready. So I think I'm just gonna use like a conditional here and say like if, wow, see, that was me with Perl. If line counter less than num rows. There we go. That sounds good. Reason being, well, I don't want to, it told me how many rows I'm going to get, so I'm just going to do it for that many and be good with it. I do less than because this is going to be indexed starting at 0 rather than, say, starting at row 1. Row 1 is actually 0, so that's what I use less than. If I started this at 1, it wouldn't work so well with an array. So, because, indexes start at 0. 0 is a perfectly good counting number. So, else, now we're not going to hit the else until s is equal, so, we'll say else if line counter equals num rows. Well, then at that point I think we've hit the line, our last line, and that's going to be our coordinate point. So do we make this object? We kind of did. Okay. Then we're just gonna do start coordinate equals new coordinate, and we'll do, what is this, maze line buffer 0 and maze line buffer of 1. Now I know I have to parse those integers because of the way I did that, but whatever. And there we go. That's good, right? Think so. Yeah, that's good. Alright. So now we've initialized our coordinate up here. That's our private coordinate. And that's going to be our starting location. Should tell us where we need to actually start the maze. So now that we should have this, we can go ahead and actually try to run it. I just want to make sure we're getting the right line for this, so let's get rid of these breakpoints and this one, and save everything and go into debug. Yes. Okay. So at this point we have our maze array here, our 5 rows. Oh wait, no, starting at 0, so that's good. 6 rows. Whew. See, I was worried. Maze line buffer 1 0. That's gonna be right. Okay, so now that should create our coordinate object, and saying class not found. That's ridiculous. It's not talking about my coordinate class. See? There we go. Perfect. Perfect. Alright, great. So now that shouldn't be ready. Now we're good, I guess. Yeah? And that was the whole program. Okay, so far. Okay, so now we have our maze object, have our maze array, so we can see each of these beautiful lines with the rows of our maze. We just have our numbers, and we have our coordinate object. It tells us where we're supposed to start. This is fantastic. Alright, So, now what? Well, now we need to start figuring out how to solve the maze. So, like I mentioned in the first video, if we follow that whole rule where we keep our hand on the wall and always look in one direction. So let's say we look clockwise. We search clockwise for an available place to move. So that's one thing we need to do. So yeah, I guess we can just do it in here. It's not really a big deal. I'm gonna just collapse that because we don't really need to see that implementation now. That we know what we're doing. And I'm also gonna get out of debug mode because, come on, we're not debugging anymore. So, what are we gonna do? We need a method that will look for somewhere to go. And basically that means it's gonna have to look from north to east to south to west. That's clockwise. So, in this particular case, I'm just going to bring over Notepad++ here. We're starting here. It's going to look here, then here, and then here. Well, it found a place to go here, so it's going to go here. And then it's going to look here, here, here. Same deal here. Now, when we get here, as you can see, we're at a crossroads. We can either go here or this way. Well, because we search clockwise, we're going to go the wrong way first. And that's going to be our first, error part of the program, is because we have to be able to figure out, wait, this is wrong. Okay, so let's back up. And then from here, we look this way. Now, basically, how I'm gonna do this is I'm probably gonna as I go through here, I'm gonna change these to ones to places that I've been, right? And then as I go here, and if I hit a dead end, I'm gonna go back, and then I'm gonna search for a 0 to go to, right? And we have to search in a clockwise formation again. So if I'm at this place now, I'm searching clockwise. Well, this is gonna be a 1 at this point, can't go there. If there are none, then we go back, but we change the spot to a 1 as well, or like a 2 as well. 2s are going to be bad, and 2s are bad spots, 1s are visited spots, and 0s are unvisited spots. How about that? And then at the very end, we'll do, well, I guess at that point, 2s will be the bad spots. So 1s can be the correct solution too. So we can use that to maybe animate through. We'll see how it goes. Okay, so basically that's what's going to happen. So we need a method to solve the maze. And really what I'm doing with this is I'm modifying that array, like I said. So I really don't need to return anything. Because whatever we're going to use to look at this array is going to use accessor methods to, I guess, get the numbers associated with it. So yeah, obviously you can tell I'm doing this as I go. And okay, so solve maze. Really, we just kind of have to iterate through this maze. So we need embedded, or what do you call it? Nested for loops. For int I equals 0, I is less than maze array. Oh wait, no, we already have variables that'll tell us, of course. Num calls plus plus. That is extremely convenient. Alright. That's actually something that we may eventually change to, because say we wanted to create a maze builder with a maze that isn't a square. Now, granted, the program would probably internally be able to say, alright, well, even though you made this crazy shape, wherever there is a wall or places that you can't go, square it off. easy enough. So theoretically, you could probably still use something like this, but anyways, okay. So and then our internal loop for int m equals 0. M is less than num calls. Actually, you know, this one should have been num rows. This one should be num calls. M plus plus. Because we're iterating through each column and each each row and each element of each row. So, where to start? Actually, you know what? Let's not do this. I'm sorry. We need to start at the starting point. So let's stay true to that. We have a start coordinate. Int start row equals start coordinate dot get row. Perfect. And start call equals start coordinate dot get call. What? We didn't make those, of course we didn't. So let's just make them. Because we have to. Okay. So we now have the row and the column. So that's the position in the array we need to go to. So we need some type of loop now. Now it's not actually, maybe we don't want it to be like a for loop. Maybe we want it to be a boolean. How about that? Private boolean. Wow, boolean. Alright. Boolean is solved. And is solved. It's false, by the way, because it does not start solved. Alright. So while math is solved, then we do stuff. First we're gonna search for a spot. So we're gonna need a method to do that. Private coordinate scout spot. And actually I'm going to need to pass it in a coordinate. You know what, let's just use a coordinate object. Why do I even need this? Use our coordinate object. So maybe I'll just use a coordinate current coordinate equals let's start coordinate. Well, we want it to be its own object. So or we can just, yeah, that's fine. Alright, so while math is solved, it is SR. I got that C there, right? Okay, scout spot. I need to pass this in a coordinate C. Sorry. I'm losing it. Let's return type coordinate. Alright, well, so what do we know? We need to look north, east, south, west. So, I'm going to first do what do I want to return? So, let's just do, let's say look north. Actually, sorry, I'm going to write these. Private coordinate, look north, coordinate C. Because I'm lazy, I'm going to copy and paste this. And that's going to be east, and it's going to be south, and this is going to be west. South and west. Okay, perfect. So basically each of these are going to look at the spot of the maze that that corresponds to what I'm talking about. Oh, and we're also going to have to handle the whole thing that, you know, if we're, say, on the far west side of the map, we can't look any further west. So, yeah, there's that. So, looking north, what's going to happen? We want to know if the spot to the north is somewhere we can move. So, let's say, well, yeah, we need a coordinate, so we are returning a coordinate. I was just contemplating using a boolean to say, hey, we can't go here, but this will work fine. So, if it's safe, maybe we'll need an isSafe method. Private check safe coordinate C. If wow, now I'm already forgetting what we called our maze object. Maze array of C dot get row C dot get call is 0, return true, else return false. Let's specify that return type just so we are all squared away there. Okay, so we have our check safe method there now. So if that spot is safe, we can return that coordinate. Sound good? Okay. So to look north, we need to look at the spot above it. So that's going to be row -1. Now that's going to be assuming that, what do you call it? It's not out of bounds. So if, actually, let's say C dot get row minus 1. This is just kind of going to be our workaround, aside from I don't want to do too much exception handling. If that is not, if it's less than 0, then we know we're going to get that return C. So we're just going to return the same coordinate if we can't go that way, which works. Else, what do we want to do? If check safe coordinate C2, no, spot, yeah, use new coordinate, and we'll do C dot get row minus 1 and C dot get call, because why not? Okay. If check safe spot return spot, else return C. Okay, that's probably good, huh? Just going through this. Oh, now I knew what I was wanting to do. I wanted to get this. Okay, so I'm thinking I can probably just copy this implementation and just change like what we're changing here, like get row, or sorry, like get row minus 1 versus, and change it. Like, so if we're looking solid, it would be get row plus 1, right? So okay, I'm assuming you said right. Not to speak for you or anything. Look west. Okay, perfect. So now for look east, it would be call plus 1. Plus 1. Now, if for this check instead, it'll be get call plus 1 is if it's greater than what, the number of rows minus 1, or the number of rows, or if it equals the number of rows. Let's say equals. Sorry, none calls, because that would mean that we'll be off on our index and we'll go out of bounds. So that's what I'm gonna go with. Yeah. Perfect. So let's see. Else coordinate spot equals that plus 1. Return spot if it's safe. Otherwise, return C. Okay. Look south. Plus 1 if it equals the number of the rows. Then I'm gonna do that. Switch it to plus 1 here. And same deal. Okay, now this is going to be minus 1. Look west. So if get call. So now we're looking at our columns and we're saying if it's greater than, if it's less than 0, then we're already on the edge. So okay. So basically we're going to look south, east, west, and where is my air, darn it. Oh yeah, scout spot, still haven't finished this. Okay, so what do I want to do here? I don't know if I want this method. I want, okay, so I'll just look north. Because I have to do it in that order, right? Right? I guess it depends on what... No. It depends on what direction I'm already going, doesn't it? No, not really. It just means I have to check the same in the same direction. Clockwise. Okay. So we'll just do that. Okay. So I just want to make sure that we have a separate object to compare this to. So return coordinate equals look north. Gosh, we could just use a boolean, right? I mean, no, because we want to have that look north. Alright, so look north at current coordinate. Sorry, I'm too indecisive apparently. So they're not the same object. We'll make another method. Boolean check same spot. Coordinate A, coordinate B. It's just easier. Okay, maybe it's not actually. If A dot get row equals B dot get row, and A dot get call, well, equals B dot get call, return true, else return false. Alright, because I love parentheses apparently, let's just branch this off so we know if it's the same like coordinate, although it's a different object. We'll tell it it's the same coordinate, otherwise we'll tell it it isn't. That's really all there is to that one. So, and the reason I made that is because I want to see up in this one if check same spot, return coordinate and current coordinate. Well, then we keep going, I guess. So we want to do if not. Let's just do if not. That way we can actually go in and say, let's do something. Continue. Okay. So if it's not the same spot, north was a safe place to go. So at that point, we want to change that current location to a 1, right? Because we've been there. So at some point here, I gotta start creating another object, another, I guess maybe a list or a stack. Basically like a queue. Not a queue, sorry, a stack. Because if I go, if I go the wrong way, I need to start popping off the wrong slots. So, anyways, so if it is not the same spot, then it's safe to go there. Naturally, right? Check safe was if it's a 0. So it is definitely safe to go there. Now, at some point, we need to know if, if none of these are, then, yeah, we'll get to that. Alright, so, if not, then maze array, wow, when did I hit caps lock? Maze array of current coordinate dot get row current coordinate dot get call. Yeah, I couldn't have chosen a worse variable name, right? Maybe you know what? I can still change that. So why not? Equals 1. That's right, I just changed this. So now I'm gonna refactor that object because I don't like that. What should we call it? There it is. Okay. Rename it. Current. It's shorter. So basically, now that spot's going to be a 1, and current equals return coordinate also needs to change. Returned sent back retrieved whatever. Sorry. Current equals retrieved. There we go. So that should go to the next part of the loop. Otherwise, retrieved would equal look east. So if not the same spot, then get the row, get the column, set it to 1, continue. Something's telling me there's going to be like a huge logic error somewhere, just because that's how it goes, but we will work through this. South. Or you just look south and do this one more time. Look west. Okay. So if we've made it to this point, spots have been the same. So really what we gotta do is we gotta back up. At this point we'd say maze array of the current stuff is gonna equal 2. So it's going to say it's a bad spot, and then we're going to have code to go back. And wow, that was the first comment I put into any of this. Isn't that terrible? Oh man, that's terrible. Okay. Yeah, I'm going to start, I'm actually going to debug this a little bit just because I want to see it work. and make sure I'm not doing anything horribly bad before we keep going. Okay, because at this point, we're going to need to go to the previous spot. So we're going to need a stack of coordinate objects. That's what we're going to need. So in the next video, we'll actually start with that. But for this video, we will press onwards and do our debug to make sure that this can do that. So let's see what happens, just for kicks. After I create the maze, I want to solve the maze, and really, it's not going to happen in like this. Excuse me, I'm tired. This is going to be called by maybe like that button we were going to press in the final thing, but yeah, whatever. I'm just going to leave it in the constructor for now. Heck, I should have that in the driver. Create maze. Okay. Those shouldn't be in the constructor. What am I thinking? I'm not. Well, those are not public methods. So now they will be. Okay, now where did I want my breakpoint? Somewhere in here. Well, solve starts off false, so let's just start it there. Boom. Create maze. Oh yeah, I forgot about that breakpoint. Boom. Alright, well, not as solved. Well, is it? Is solved? No, it's not. So retrieved equals look north. I'm gonna step over that. So let's take a look at this. We got 0, 1, 0, 1. So I'm also gonna look at my notepad file. Okay, we should have gotten that because we can't go north. That's right. So look east should be this one now. So that one we should get a different one. Whoo! Alright, cool. So it's gonna go over to this. Oh, yeah, forgot about this method. Okay. So now it's gonna go here, look east. We're gonna get out of that. So now they should not be the same, which they're not. So it's 1, 1. So now we are going to the right location. See, we're moving to the right. Okay, now I'm very, actually I'm relieved that that worked right. But I'm going to keep going and I'm going to see, because I want to see that we go to this spot, which is, what, 0, 1, 2, 3, 3, 1, before we go to the other way. So, yeah, and so we should go into here and return there. So, okay, now let's take a look at our maze array again. And maybe not everything at once. So we're on this row. This should change to a 1 with any luck. And of course we gotta call both of those. So huzzah! That was our first spot. Yeah, no. So I'm making this sound crazy. I'm probably making this way more complicated than it needs to be, but that's what I do. So yeah. Anyways, let's set this to here. Okay, so now we're in that spot. We also need to go right again. I'm just gonna keep going like this. Boom. Boom. Okay, and the last one's gonna be a 1, and it's not gonna know what to do at that point because it can't do anything now. I'm going to set a breakpoint down here. Boom. Okay, we got here. We didn't get into anything, so this should change to a 2. Like I said, that should change to a 2. Okay. Interesting. the next row. Oh, because we were able to go south. Derp. Okay. So, like I said, if I look at this maze here, like if I show you the maze, we went here, 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 and then here, and then we hit a wall, right, because we couldn't go anywhere else. So now this is a 2, and we're going to have to pop out of the stack now, and then, until we get back to this point where we can go this way again. So yeah, anyways, that's where I'm going to leave the video for today. In the next one, we'll start by making that stack that we're going to need to have our solution. And then after that, you know, that might actually finish off our solution. Well, by that time we should have the solution, and then we can start working on the user interface. So yeah, catch you on the next one.